Good morning. Welcome to our presentation on Semantrix, Semantic Fusion. It's a new approach to information integration, consolidation and publishing, driven by sensor and other information feeds. The core system uses data analysis, text analysis, and a conceptual fusion and semantic publishing model under the covers. Originally targeted at situational awareness, homeland security, customs, defence, police, anti-terrorism, Semantic Fusion delivers a concept-level fusion, and this is based on a data fusion process using agent and semantic technologies, but also extracts concepts and uses agents to implement a condition of interest monitoring and response capability, has a dynamically extensible model for user interaction, and a backplane model for integrating multiple silos of information. This is built on top of another product concept that Semantrix has been building out, intended to manage multimedia content, analysis, annotation, cross-referencing, generating appropriately tagged metadata, and then the ability to extract that in a geo-tagged model. As an example, a UAV may have had a field of view at a time covering a certain area. We would be able to retrieve that information. So we can link multiple information and also textual assets together at any point in time. So semantic fusion is based on the idea that improved situational awareness requires high-level conceptual representation and reasoning capabilities. It approaches data fusion from an agent ontology and concept modeling perspective rather than a traditional data analysis approach. So some of the key business opportunities are to integrate silos, to reduce operator cognitive fatigue, integrating the condition of interest monitoring and response capability, as well as text analytics to extract the relevant bits of information that a particular operator, i.e. an electronic intelligence operator, would need while working and looking at significantly large volumes of data, hundreds of meg of information. It also allows for high-level concept extraction relevant to the business or application needs. Again, this core can be tailored to suit other domains other than just defense situational awareness. Has a very extensive capability and query model, and can increase your usage of information by integrating multiple disparate bits. It's not just sensor information, it's sensor plus electronic intelligence, plus voice transcripts, plus other textual information sources all combined together. Under the covers, the system is able to maintain an object in terms of it being unknown, but with a high confidence. It's a truck, a tank, a car, or whatever other type of classification model you have, and combine the probability or the certainty of that classification together. Semantic Fusion, again, can drive automation, and it can support multiple levels of user access and control. So Semantic Fusion ingests data from a wide range of information feeds from physical sensors on. Analysis agents interpret that data, carry out a data fusion process, extract out the concepts, put the concepts into a working area, and then monitor that using conditions of interest and generate appropriate responses, which a user can register, or the system can register, or can be registered by other higher order organizational elements, i.e. a battalion may have default conditions, a platoon may have default conditions. There are lots of ways that this information can be managed. And finally, we have a flexible sense, communicate, reflect, and act model. So once we receive that information, we alert operators, we alert systems, we generate an appropriate layered set of behavioral responses. So the foundations of semantic fusion. It's not like any other technology set that you've probably worked with or seen. We use domain-specific languages, we use text and ontology-based models and semantic web technologies across the board. We have a constrained expansion model which allows us to extend out automatically and display information of various types. We also have our sense, our reflect, communicate model, and our act elements. So the information is processed, it's distributed internally amongst entities, it's then reviewed and a particular response pattern generated, and then we act. And that action may take into account planning, simulation, response, reactions. Again, it's not an ontology-only technology. It's not just a data fusion model. It works with and extracts concepts mapped to specific domains. It's a unique technology approach. It's unlike anything else you've run into at this point. So some of the platform capabilities: enhanced situational awareness, context-aware integration of sensors and other information sets. The sense, communicate, reflect, act agent-based model to allow us to extend arbitrarily. Again, our use of semantic web technologies allows for a distributed system to be developed, and for systems to work with only the data relevant to them, i.e. a man-portable device can have all the information sets relevant for 1 kilometre radius. And that's all that a soldier in the field may need. And that can be connected to a larger set through the networks and work with larger sets of information. We could have a radar processing node in Adelaide. We could have hydrophone management in Sydney. We can have different areas concentrating that information, extracting concepts, and then just moving the concepts around in the network, a very major reduction in communications bandwidth. Again, we have our condition of interest monitoring system, which can be arbitrarily delivered to a person. We've got prototype versions of this which distribute to handheld devices just the information relevant to a particular operator. And again, we can have planners, real-time semantic agents and planners, allowing us to work with the information currently known, plan out an activity, i.e. logistics, transport, using the world model that's maintained internally, and decide the most appropriate way to respond. We also have the potential for time-constrained reasoning, which means we make a decision within a time frame. It may not be the best decision, but we will make a decision in that time frame. So, some examples of conditions of interest. If an enemy is within a kilometre, then go into a scout mode for a platoon. If we find that it's actually an enemy tank, then we retreat, because that's something we can't handle. The system has the context of a hierarchy of representations of relationships between objects and is able to reason around them. Enemy, enemy battalion, enemy platoon, enemy soldier within that grouping, and everything underneath that will be treated as part of that part-whole relationship. We also have ontologies to represent typical actions, and we use that to drive a simulation capability under the covers as well. Again, we use domain-specific languages, so the language for police may vary from the language for defence and army personnel, but we can provide a mapping between their terminology. Okay, so people can communicate in a way which suits them, and also have other groups understand what that information is if there's an appropriate mapping. And again, hierarchical response and planning activities are supported. So we have a number of demonstrators, which we will talk about independently and have separate video displays. We have a scenario showing a private falling behind a sergeant as part of a platoon. Once he reaches more than 100 metres away, the platoon sergeant is notified that the private has fallen behind, and the private's told to catch up. What's that? If we can have automated sensor information driving a response from a platoon to go and look at something new in the environment. We have another scenario which is operational, which is our check it out scenario, which has a tank trigger off an audio sensor. The classifications, possibly tank, maybe a truck. Once we've actually got additional information, we trigger off a flyover from an enemy UAV, from a UAV to determine the enemy and work out whether it's a tank or truck. And based on the fact that it's actually a tank in this case, the platoon is told to retreat automatically. We have another scenario, run away. Again, if enemy tanks detected, we automatically trigger off a retreat by the platoon. And their final one was an example using interacting UAV planners and UAV management agents. Again, we can delegate elements within the system to interact and represent the behavior of a certain node, i.e. a UAV. In this situation, we have a fast UAV with a low resolution sensor able to do a fast but shallow scan of an area. If it finds something useful, it designates a target to a second slow but high resolution sensor equipped UAV, which then goes and does a high resolution scan of the immediate area around the potential sighting. So this could be an example of a search and rescue, of a mission to detect enemy units and then pinpoint how many units are in that area. And this continues on. Again, it's possible to interrupt the behavior of the scouting and to have the system continue on. Now, I said we'll have detailed views of these showing how they work as part of separate presentations. So other use cases, intelligence monitoring. We have communication intercepts, we have threats and assessments, we extract keywords or materials purchases, extra purchases of food and supplies around an enemy village may actually indicate there's an enemy grouping or terrorist grouping in that area. So we can monitor and work with that information in a different way. So the advantages and benefits of the system. Smart automation allows users to maximize their time on tasks requiring human cognition, automates a lot of the processing, filters out irrelevant information, and tells you when you've got something which is relevant to what you've indicated is important. Agent technologies, new information processing approaches, semantic web technologies, integrate your legacy systems, do smart things, have agents monitoring the information of concern to you all the time, looking for changes or sets of circumstances, i.e. conditions of interest or scenarios becoming true, and then trigger off appropriate response. It's decentralized. We can break the system up across multiple nodes. It can be man portable. It can be linked with augmented reality displays. So a person in the field could actually overlay the information set coming in from sensors on a UAV or sensors in the field over their display in their hand, tied in with a GPS and direction systems. We can then have that information overlaid. These are the minefields. These are the sensors. Here's the potential enemy locations. Again, very complex information displays can be moved around and created automatically based on our use of concepts and our tagging of the information, and we minimize our data transfers. Low bandwidth is required. Again, very extensible. It's a unique technology set. So some of the potential application areas for demonstrators: situational awareness for emergency services, disaster police, localized soldier decision support, using conditions of interest, real-time sensor mapping, concept-level data fusion, integration of text and sensor feeds to help bias and improve the confidence in a particular response, semantic agent and planner integration, as we said, autonomous vehicle management. So again, hierarchical planning, adaptation, mission management are all potential outcomes of this system. We have some demonstrations. Sense and avoid, again, smart sense and avoids using other information other than just the vehicle sensors. We may know that a commercial air flight is due in an area at a time and integrate that into our mission planning and path planning software. So, where can we help? Well, Semantrix can help in a range of areas. Next generation situational awareness, as you've seen, we have new technologies for information management, publishing. We can automatically integrate sensors with sensor capability information, so we can tell whether it's a UV, UV vis, a vis-only visual sensor. We can integrate information appropriately based on that. We can potentially support a fly-through of a UAV based on our knowledge of the sensor capabilities. Again, data and concept fusion, text analytics, semantic enrichment, the ability to integrate with GIS systems and provide a significantly enhanced query capability, geographically based, time-based, sensor capability-based, and also targeted via the user's requirements. Again, major level enterprise and custom search capabilities. And again, our partners have been heavily involved in a range of very interesting areas overseas, as have we locally. So please feel free to call us. We look forward to your support.